Hello everyone, again welcome to our today's lecture, that is limit, fit, tolerances and gauges part number 3. Myself Mr. Bipin Patil, lecturer, Department of Mechanical Engineering at Sharad Institute of Technology, Polytechnic, Yatra. So today we are going to learn about the hole based system and shaft based system. So let us see the previous content what we have learned in previous lecture. In previous lecture, we have seen the classification of limits, that is limit of hole and shaft, maximum limit, minimum limit, then classification of tolerances, that is bilateral tolerance, unilateral tolerance, compound tolerance, geometrical, etc. Then finally we have seen the Indian standard fits, that is clearance fit, interference fit and transition fit. Today we are going to learn about the hole based system, shaft based system and designation of a fit. So let us see the today's lecture content. Today we are going to learn first of all hole basis system. What is meant by hole basis system? Then we are going to learn shaft basis system. Third, Indian standard system of limit fits, that is IS 919-1993. Then guide for selection of fits. So starting with today's content, hole basis system. Let us see what is meant by hole basis system. So in simple language we can see the size of hole is kept constant and the shaft size is varied to give various types of fits. That is the hole basis system. In hole basis system, the size of a hole is kept constant. You can see here. Then lower deviation of the hole is 0. That is, the lower limit of the hole is same as the basic size. For example, if the diameter of a basic size or dimension of a basic size is 25 mm, then the diameter or the lower limit of a particular hole is 25 mm. Two limits of shaft and the higher dimension of the hole are varied to obtain the desired fit. Here you can see in the image the representation of a hole basis system. You can see here hole is constant with its tolerances and the dimension of shaft varied here. In image A you can see that the clearance fit that shows the tolerance zone of a hole varying at a unilateral, the basic size is same or which is matching here with 0 line, or we can say it as a 0 fundamental deviation. This particular hole is having only one maximum limit. In figure A you can see here the hatch line that shows the shaft tolerances. Here you can see it is below the 0 line, so that the type of fit is a clearance fit. So in particular system, in figure A, B, C, you can see here the tolerance zone of a hole is a constant at 3 types, here, here and figure number 3, C, here. You can see. So in middle figure or figure number B you can see this is a transition fit. 3 shaft zones are shown here. All 3 shafts working with transition fit, that is interference as well as clearance fit. Then figure C you can see here the limit of a shaft is higher than the higher limit of a hole. So it is an interference type of a fit. Basically, you can see here the all shaft zones are varying, but the hole tolerance zone is continuously constant. So that we can call it as a hole basis system. So let us see what is meant by shaft basis system. So why hole basis system are preferred and where the hole basis systems are preferred? Let us see. Hole basis system is preferable because holes are produced by standard size tools, that is drills, reamers, broaches, etc. But shafts are manufactured by turning or grinding process. Hence, it is convenient to produce various sizes of shaft than holes of various sizes. So here you can see in image there are a 5 types of a reamers: 25 diameter, 30 diameter, 32 diameter, 35 and 38 diameter. These are the standard reamers. So if you want to produce a hole of 35.8, you cannot produce the particular size of hole. So it is difficult to vary the size of a hole. You can see here one broacher or one reamer producing the hole by using this particular standard type of a reamer. So you cannot produce a customized sizes, that is 38.38, or you cannot produce 30.5. Here you can only produce the standard size of a hole. So it is easy to produce hole rather than shaft. So let us see what is meant by a shaft basis system. With minor difference, the shaft basis system is also same with respect to hole basis system. That is, the size of shaft is kept constant and the hole is varied to obtain various types of fit. Please focus here. The hole is varied. So as we have discussed earlier, it is too much cumbersome to vary the hole and it is costly. So let us see what is exactly the shaft basis system is. The fundamental deviation or the upper deviation of the shaft is 0. System is not preferred in industry because as it requires more number of standard size tools like reamers, broaches and gauges, increases manufacturing and inspection cost. So as we have discussed earlier, it is too much costly to carry the cost of standard tools like reamers, broaches and gauges. So it is too much easy to control the dimension of shaft rather than controlling the size of a hole. So let us see by graphical presentation the shaft basis system. In this figure you can see it is so much same as hole basis system, but here the tolerance zone of a shaft is kept constant and tolerance zone of a hole is continuously varied. So you can see in figure number A, that is the clearance fit. Here you can see the upper deviation of a shaft is matching with the zero line. That is, it is the fundamental deviation. So this shaft is having only one side, that is lower deviation of a shaft. So the upper deviation of a shaft is 0 and the maximum limit of a shaft is equal to the basic size, or we can say it as a matching with the zero line. So in figure number B you can see the transition fit. The shaft of diameter of a shaft is varying in 3 stages. Here you can see 1, 2, 3. So it will give you the interference fit, it will give you the clearance fit. Both are giving you the clearance fit. So here you can achieve clearance as well as interference fit with their tolerance zone. In final tolerance zone you can see the hole is less than the shaft diameter. So here it is clearly seen that it is a type of a interference fit. But in three images, you can clearly find that the shaft zone is continuously constant. So it is a shaft basis system. So let us see where the shaft basis system is preferred. Shaft basis system is preferred for long shafts of full lengths. For example, if a shaft is meeting with at least two parts having hole that need different types of fits. So mounting of a bearing is a one type of example. Second, we can see the example assembly of piston pin with piston and connecting rod. You can see in image there is a piston pin or gudgeon pin which is going to assemble with piston as well as the hole of a connecting rod. So it is required to maintain two different diameters to match with the same type of a fit. So here there is shaft base system is preferred. So as we discussed about the basics of hole basis system and shaft basis system, so coming to some basic differences between hole base and shaft basis. So let us see the first difference. Size of hole whose lower deviation is 0 is assumed as the basic size of a hole basis system, where size of shaft whose upper deviation is 0 is assumed as the basic size in shaft basis system. Where second difference, limits on the hole are kept constant and those on shaft are varied. So you have seen that the hole basis system keeps the limit of holes constant but varies the limits of shafts. In second difference, in shaft we can see limit on the shaft are kept constant and those on hole are varied. Exactly opposite. So the third point is system is preferred in mass production because it is easy, convenient and less costly to make a hole of a correct size. Whereas the system is not preferred in mass production because it is inconvenient and costly to make a shaft of a correct size. As we have seen in preferences previously, so it is clearly seen that to maintain a correct shaft size is quite costly. So we moved or we jumped to the hole basis system. Fourth point, it is much easier to vary the shaft sizes according to the fit required. It is rather difficult to vary the hole sizes according to the fit required. Here in image you can see the difference. Point number 5, here all the tolerance zones of a hole are kept constant here. 1, 2,
3. Then for shaft, it is clearly seen that the shaft tolerance is kept constant. 1, 2, 3. Then coming to the next point, that is sixth point, it is designated by capital H and shafts are designated by small h.
So we have seen the basic differences between hole basis system and shaft basis system. We have seen why to prefer the hole basis system. So next we are coming to Indian standard system of limit fits, that is IS 919-1993, and according to Indian standard the system of limits and fits comprises 18 grades of tolerance and 25 types of fundamental deviations. They are indicated by letter symbols for both hole and shaft. So capital letters, capital A to Z and capital Z to the suffix A, suffix B and C for hole, and small letters small a, small b to the small zc for the shaft in diameter steps ranging from 1 mm to the 500 mm. It is a standard size. A unilateral hole basis system is recommended, but if required, unilateral or bilateral shaft basis system may also be used. So IT grades refers to the international tolerance grades used in industrial process. These grades are used in designing a part with desired specification. IT grades identifies amount of tolerance for a given process and for a given dimension. So in the design point of view, the IT grades are important, and what kind of IT grades are used to get the desired fit. So in next content we are going to see what is meant by IT grade. So let us see. Here in the screen you can see the grades of tolerances. There are 18 grades of tolerances. IT01, IT0, IT1 to IT16. So let us see how tolerance zones are divided to manufacture different types of processes. Let us see. IT01 to IT4, it is preferred in manufacturing of gauges, measuring instrument. Then IT5 to IT7, these are used in precision engineering applications. Then IT8 to IT11, these are preferred for general engineering purpose or general engineering works. Where IT12 to IT14, these are preferred for sheet metal working. Finally, the IT15 to 16, those are used in casting and general cutting work. Further, it is given in detail, that is IT16 grade is used sand casting, flame cutting. Then IT15 is used in stamping. IT14 is used for die casting or molding and rubber molding work. 13 used for press work, tube rolling, etc. So on the 12th, IT grade can be used for light press work, tube drawing processes. Then the IT11 grade is used for general purpose like drilling, rough turning, boring, precision tube drawing, etc. And 10th, milling, slotting, planing, metal rolling or extrusion process. Likewise, the 5th and 6th and 5th finally are used for grinding, fine honing, and finally machine lapping, diamond or fine boring process or fine grinding process can be achieved using the tolerance grades. So this is in detail IT tolerance grade preferences. So in this table you can see the particular standards of a IT grades, which is starting from IT5, IT6 to the IT16. So it is particularly mentioned the values of a IT grades. For IT5, the tolerance is given 7I. For IT6, it is 10I. IT7, it is 16I. For IT8, it is 25I. So on up to it is IT16. IT16 having the value of its IT grade up to 1000I. So what is meant by an I, and how I is calculated, and how the value of IT grade take in a particular or particular defined units. So here the formula is given to calculate that particular I constant. Here we can see the small I is equal to 1 upon 1000 in bracket 0.45 to the third cube of a D plus with 0.001 constant, it is multiplied by the diameter range. Here the capital D is the diameter range in which your particular shaft diameter is lying. So let us see how the tolerance allocation is done. Here the standard tolerance unit I is calculated as we seen previously. So the capital D is a geometric mean of the lower and upper limit of a diameter step in which the dimension lies. So we can see it as a diameter of a shaft or the external features of particular diameter. So here you can see the diameter steps, that is ranging from 1 to 3, 3 to 6, 6 to 10, 10 to 18, 18 to 30, 30 to 50, 50 to 80, up to the 500 mm. So this is a standard tolerance grade of a shaft in which you can calculate the tolerance zones of a hole and shaft, and you can achieve the required type of a fit. So let us see how exactly the fundamental deviation is kept between hole and shaft. So after calculating the particular 18 grade tolerance zone values, so we have to jump on fundamental deviation. As you can see on a screen, there is a fundamental deviation with respect to the basic size or a zero line. Here you can see the hole tolerance zone in hatched section and shaft tolerance zone in dark black box. So as we have earlier discussed, there are a 25 types of a particular fundamental deviations or a tolerance zones with respect to the desired fit. So here hole are designed by capital letters. So letter A to G, those are oversized holes, and letter P to ZC, those are undersized holes. Here clearly you can see it is coming from a upper left corner to the lower right corner. Here you can see the particular ZC, it is undersized hole. Why it is called undersized? Because it is minimum or it is less than the basic size. Here you can see the zero line. From zero line it is having this particular kind of deviation. So it is a fundamental deviation because the upper line of a hole or the upper limit of a hole and the difference between the basic size and upper limit of a hole is called the fundamental deviation. So here clearly you can see that ZC, where capital A, you will find that the hole is oversized. Similarly, for the shaft, you can see the tolerance zone in dark black box. Here a small a presenting a tolerance zone with clearance fit. Why we are calling it clearance fit? Because it is the basic size or a zero line, and this particular zone is below that zero line. So it is a preferred clearance, or we can say it is a allowance. So it is a clearance type of a fit because both upper limit and lower limit of a shaft are less than the basic size. Similarly, you can see the small b is a clearance fit, small c, cd, then small d, small e, ef, f, fg, g, up to j, you will find that there is a clearance fit. So here at the middle you can see the capital H hole and small h hole, those are used for fundamental deviation, which is having the zero size of a lower limit for hole and upper limit for shaft. So shaft are designed by small letters, letter small m to small zc, those are oversized shafts, and letter a to letter g are undersized shaft as we seen earlier. So here you can see from lower left corner to upper right corner as a curvy motion of a particular zone, tolerance zone, you can see here. So at the extreme upper side, the ZC is having more dimension than the basic size. So clearly you can see both the limits, upper limit and lower limit of a this particular tolerance zone is greater than the basic size, so that the hole is small and shaft is having maximum dimensions. So clearly it is seen that it is interference type of a fit. So coming to the next representation. So representation of a tolerances. So in previous screen we have seen that the shaft tolerances and hole tolerances, here they are divided with different zero lines or basic size lines. Here you can see the one line and here it is the second line. These are the limits of a or the deviations of a particular hole, and these are the deviations of a shaft. So you can clearly identify with the capital and small letters. Capital letter representing the hole tolerances, whereas the small letter represents shaft tolerances. So the selection of letter freezes one limit of the hole or shaft, how much they are away from the basic size. Here you can see the capital E, that is showing the fundamental deviation of a whole system, whereas the small e showing the fundamental deviation of a particular shaft. So representation of a tolerance, the letter symbol, here you can see 45 E8 or E7, how it is represented. Let us see. The 45 is a basic size. Here you can see the basic size, the particular number showing the size of a hole or a shaft. What is mean by capital E? Here you can see the capital E, which is showing the tolerance zone. Okay, then already we have discussed the number 8, which is standardly given for IT grade of a hole, because it is attached with hole, so that it is a IT 8 grade for a tolerance of a hole. Similarly, small e shows you the deviation of a shaft from basic size, and similarly the number 7, it is the IT grade of 7 for a tolerance zone of a shaft. So one can have the different possible combinations, for example 45H6 G7, 45H8 R6, 45E5 and P7. From this you can find the which kind of particular fit you have achieved. So let us see. Here you can see the fundamental deviation of a this kind of fit is H6, which is a standard hole, which is seen here, whose fundamental deviation is 0 and having the unilateral tolerance, that is the tolerance is having at a only positive side. So this is mating or assembled with G7. So here you can see where is the G. Here you can find out the G. So clearly you can see that it is the less than the basic size. So the shaft size is having less than the standard hole size. So clearly it is seen that there is a clearance type of fit. So you can directly comment by using this logic, this is the clearance type of fit. So coming to the next concept, that is ES, upper deviation, and capital EI represents the lower deviation. Here it is. This is the upper deviation of a hole and lower deviation of a hole, capital EI. So capital H lower deviation of hole is 0, as we see here you can find. Then small h upper deviation of a shaft is 0, as we have seen earlier. So coming to the next fit, that is 45H8 R6. So again the fundamental deviation of a H is a 0, so it is a constant. Coming to the R, you will find the shaft zone here PQR. So the shaft tolerance is showing that these are maximum or more than the basic size. So the shaft is maximum than the hole size, so that it is clearly find it is a interference type of a fit. Likewise, you can identify with this representation the type of fit and basis of a system. So let us see the next content. So after the basic terms, we are jumping to the representation of fits. So how exactly in industry the representation of a fits is done in a particular assembly? So let us see. So capital H7, small f8, what is the meaning of this with respect to the fit and basis of a system? So here capital H represents hole basis system or type of a hole, where the 7 represents IT grade 7 for IT7 hole, that is value of tolerance 16I in micron, as we have seen earlier, where the small f indicates type of shaft and 8 indicates IT grade 8 for IT8 shaft, that is the value of tolerance 25I, which is in micron. So it is the representation of it. Let us see how exactly the nomenclature of a fit is done. So coming to the interpretation of a type of a fit, here you can see 535 H8 F7, that is clearance with normal running fit. So in university or board examination, you will find such kind of question, that is explain the meaning of 35 H8 F7 with respect to fit and hole basis of a system. So here we can explain the meaning of 35. It indicates numerical value of basic size. Capital H, as we earlier seen, it indicates type of hole. Here H is the hole basis system. So the whole system is hole basis system because hole is kept constant. And 8, it is IT grade 8 for IT8 hole, that is value of tolerance is 25I in micron. And small f indicates type of shaft. 7, that is IT grade 7 for IT7 shaft, that is value of tolerance 16I in micron. Likewise, you can find out the 535H8 I7. You will recognize which type of fit it is. Then second, 27H5F6. Here again the capital H represents the hole basis system. Then in third, you will find out 45H7P6, and fourth, diameter 30, that is the numerical value of basic size is 30, H7 and J7. So these are the different types of fits. So in summary, we are going to see in detail the types of fit with respect to the interpretation. So these are some standard recommended fits for achieve the clearance. So here it is, types of fit, loose running fit. So for loose running fit, we have to choose H11 hole and C11 shaft. It is suitable for loose pulleys and the looser fastener fit where freedom of assembly is of prime importance. Then for second free running fit, we have to choose H9 and D10 where accuracy is not essential but good for large temperature variation, high running speed and heavy journal pressure. Third one, we can see close running fit. We can recommend H8 F7 suitable for lubricated bearings, greater accuracy, accurate location where no substantial temperature difference is encountered. Sliding fits, we can recommend H7 G6 suitable for precision location fits. Shafts are expensive to manufacture since the clearance are small and they are not recommended for running fits except in precision equipment where the shaft loading is very heavy. And finally, locational clearance fit, we can recommend H7 and H6 provides snug fit for locating stationary parts but can be freely assembled and disassembled. Similarly, for a transition fit, we can recommend H7K6 locational transition fit for accurate location comprises between clearance and interference. Then push type of fit, that is H7N6 transition fits averaging little or no clearance and no recommended for location fits where a slight interference can be tolerated for the purpose, for example, the eliminating vibrations. Then going to interference fit, here it is recommended H7P6 for press fit suitable as the standard press fit into ferrous, that is steel, cast iron assemblies, etc. Then dry fits suitable as press fit in material of low modulus of elasticity such as light alloys. Here we can find out H7 S6. So it is all about our today's lecture content, that is hole basis system, shaft basis system, interpretation of a types of fit and limit. In upcoming next lecture, we are going to learn the calculation of a IT tolerance grade for both hole and shaft. We are going to learn the gauges, type of gauges, classification of gauges and design of gauges. So thank you for today's lecture. If any queries, comment down below. Thank you.